Lesson 3, Rational Exponents, Part 1. Our goal is to simplify and evaluate powers with rational exponents. Using our power of a power law, we can see that 4 squared to the power of 1/2, we would multiply those exponents, and 2 times 1/2 is 1, so we end up with 4 to the power of 1, or 4. If I evaluate inside my brackets first, 4 squared becomes 16. 16 to the power of 1/2. Well, we're not sure what that 1/2 exponent means, but in order to end up with equivalent answers here, we would have to take the square root of 16. Another way to look at it is to use our product of powers law. We see that 5 to the 1/2 times 5 to the 1/2. We would add those exponents, so 1/2 plus 1/2 is 1. So we would end up with 5 to the power of 1, or 5. We also know that root 5 times root 5 is equal to the square root of 25, and the square root of 25 is 5. This means that 5 to the power of 1/2 has to be equivalent to the square root of 5. Raising a number to the exponent of 1/2 is equivalent to taking the square root of the number. Raising a number to the exponent of 1/3 is equivalent to taking the cube root of the number, and so on. Write each power as a radical. So no evaluation here, just rewriting it instead of as a power, as a radical. So 27 to the power of 1/3. This 3 becomes our index, so we want the cube root of 27. In part B, our index is 5, so we want the 5th root of the base, and the base is -40. In part C, first thing to deal with is that negative exponent, so I want the reciprocal of 5. Then I have 5 to the 1/2. The 1/2 means take the square root of 5, so I end up with 1 over root 5. Example number 2 has us going the other way. We're starting with it in radical form, and we want to write it as a power. So our base is 12. This cube root tells us that our exponent has to be 1/3. Our base in part B is -30. And because the index is 5, means that my exponent is 1/5. In part C, I have 1 over, my base is 5, and the square root means to the 1/2. I could also write this as 5 to the power of -1/2, because 5 is the reciprocal of 1/5. Evaluate each power without using a calculator. So this time, we need to actually simplify those answers further. We already looked at 27 to the 1/3 is the same thing as the cube root of 27. We could prime factor 27, and you should find that the cube root of 27 is just 3. So we have an answer of 3. In part B, we have 0.49 to the power of 1/2. So this means that I want the square root of decimal 49. The square root of decimal 49 will be decimal 7. Part C, my base is -64. I have an exponent of 1/3, so I want the cube root of -64. The cube root of -64 will be -4. Again, we can use our factor trees to get to that point. Part D, 4 over 9 all to the 1/2. So I have the square root of that base. I can also write this as the square root of 4 over the square root of 9. The square root of 4 is 2. The square root of 9 is 3, and so it simplifies to 2/3. Part E, I have a negative exponent, so take the reciprocal of 9 first. Then I'm going to deal with that exponent of 1/2. So the exponent of 1/2 says take the square root of 9. The square root of 9 is 3, and so I end up with an answer of 1/3. A fraction can be written as a terminating or a repeating decimal, so we can interpret powers with decimal exponents. So for example, 0.2 is equivalent to 1/5. So 32 to the power of 0.2 is equivalent to 32 to the power of 1/5. Let's look at some examples. 25 to the power of decimal 5. Perhaps you already recognize that decimal 5 is the same thing as 1/2. But what if you don't? Because the 5 is in the tenths spot, we end up with 5 over 10, which is equivalent to 1/2 when we reduce. Okay, we need to simplify 25 to the power of 1/2. That 1/2 says take the square root of 25. The square root of 25 is 5. 16 to the power of decimal 25. Decimal 25 is the same thing as 25 over 100, or 1/4. So this means take the fourth root of 16. The fourth root of 16 is 2. In the next one, we already discovered that decimal 2 is 1/5, so this is equivalent to negative 32 to the power of 1/5. That means that I want the fifth root of negative 32. Well, the fifth root of negative 32 will be negative 2. Again, we could do our factor tree and make 5 equal groups to simplify that. 49 to the power of negative 0.5. I know that 0.5 is 1/2, so this is equivalent to 49 to the power of negative 1/2. Dealing with the negative means take the reciprocal of 49. So I have 1 over 49 to the power of 1/2. The exponent of 1/2 means take the square root of 49, and the square root of 49 is 7, so my simplified answer is 1 over 7. Here's some more to evaluate. The square root of 64. The square root of 64 is a perfect square, and so our square root is 8. If you need to make a factor tree, please do so and make 2 equal groups. The cube root of the cube root of negative 64. Cube root of negative 64 will be negative 4. Again, we can use our factor tree and work out 3 equal groups. Each group will have 2's inside. The fourth root of 81. So I'm making 4 equal groups with my factor tree. And in each of those groups, we will have a factor of 3. The last one we are going to omit for today. Our laws of exponents continue to work with rational exponents. So a couple of days ago, we looked at our laws of exponents. Today, we're adding fractions into that mix. So I have x to the power of 1/3 times x to the power of 4. I'm multiplying bases, so I need to add my exponents. So I would have 1/3 plus 4. You can use your fraction button on your calculator to add those, or you'll have to add them with common denominators. So I'll do this one with common denominators. Going to make this 4 over 1. If I want to have a common denominator of 3 in both cases, would mean that I need to multiply the top and bottom of the second fraction by 3. So 4 times 3 is 12. Adding, we add the numerators. 1 plus 12 is 13 over 3. So we end up with x to the power of 13 over 3. I would strongly suggest that you use a fraction button on your calculator so that you don't make unnecessary errors. In the second one, we are dividing the bases, so we need to subtract the exponents. So we need to do x to the power of 3 minus 1/2. If you are using your fraction button on your calculator, you should be able to do 3 take away 1/2, and we get an answer of x to the power of 5/2. In the last example, I have a power of a power, and so we need to multiply those. 4 is like 4 over 1, so we would have t to the power of, we multiply negative 2 times 4 is negative 8, over multiply the denominators, 3 times 1 is 3. Or again, we could use the fraction button on our calculator to check. Please try practice number 3.